Friend, we are here in this video discuss about alternating series. When the sign of the terms of the series are in alternate positive or negative, the series is called as a alternating series. For example, 1 minus 1 by 2 plus 1 by 3 plus 1 by 4 minus 1 by 4 plus like this. The sign of the series is an alternate and therefore this series is called as an alternating series. Now we discuss one test for of convergence of an alternating series. Leibniz test. The statement if the alternating series u1 minus u2 plus u3 minus u4 plus where un greater than 0 for all n is such that first condition un plus 1 is less than equal to un for all n, and second condition limit of un equal to 0, then the series converges. This is the statement of an alternating series given by Leibniz. Here there are two conditions. First one is a un plus 1 less than equal to un, and second limit of un equal to 0. So let us take the partial sum. Let us see the proof of this. Let Sn equal to u1 minus u2 plus u3 minus u4 plus up to minus 1 raised to n minus 1 into un. This is a sequence of partial sum of the series. Now for all n we have s2n plus 1 minus s2n. This will be this contains u2n plus 1 minus u2n plus 2, these two terms. S2n up to s2n term will be cancelled. We have taken a positive even terms and odd terms. Now you can see that this u2n plus 2 is a less than this u2n plus 1. This is a positive and greater than this term, and therefore here this is greater than equal to 0. So this implies that s2n plus 1 minus s2n is greater than equal to 0, or s2n plus 1 is greater than equal to s2n. That means this sequence s2n is monotonic increasing. Now what is s2n? s2n equal to u1 minus, we write this as a u2 minus u3 minus u4 minus u5 dash minus u2n minus 2 minus u2n minus 1 and minus u2n. Since u2n is a definite have a definite sign, we can see that u2, u4, u6 have negative sign, and therefore definitely obviously this u2n term have a negative sign here. Now here you can see that u3 is smaller than u2, so this is a negative term. This is positive, this one is a positive term. u2 is greater than u3. Here u4 is greater than u5. So this is a positive. This one is also positive. So every term is a positive. We get s2n which is obtained by subtracting each bracket from u1. Okay, so that means that this s2n is a less than u1 for all n, Now here S2n is a monotonic increasing and bounded sequence. Therefore, S2n is a convergent. S2n is convergent. We get an important part, and that means it has a limit. So let us suppose that S2n equal to S, limit of S2n equal to S. But friend, we know that S2n plus 1 equal to S2n plus U2n plus 1. This is an odd term and its sign is at positive. Okay, so let us take the limit of this. Limit of S2n plus 1 equal to limit of S2n plus limit of U2n plus 1. Now see the limit of un equal to 0. So limit of this term equal to 0. Limit of this term is equal to yes. So limit of s to n is equal to yes. That means odd term sequence of partial sum and even term of sequence of partial sums both converges to the same number. S to n converges to yes. S to n plus 1 converges to yes. Even term partial sum sequence converges to yes. Odd term sequence of partial sum converges to yes. Okay. Now we show that any term also converges to the same number. So let us write once again this conclusion. Both the terms, even term and odd term, converges to the same number. That means we have limit of s to n equal to s equal to limit of s to n plus 1. Now by definition of limit, for epsilon greater than 0, there exist two positive numbers m1 and m2 such that mod of s to n minus s is less than epsilon for all n greater than equal to m1, and mod of s to n plus 1 minus s is less than epsilon for all n greater than equal to m2. Okay, that means which term? For all n, this term s to n greater than equal to m1. Suppose we have 1, 2 up to m1, and here is suppose m2. Then for all n s to m plus 1 s to m m1 comma s to m1 plus 1 s to m1 plus 2 dash dash dash, all this term minus s is less than epsilon, and which term s to m2 plus 1 comma s to m2 plus 2 dash 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 minus s is less than epsilon, this term. Okay, now let us consider the maximum of this. Suppose we have maximum of this. Let m is equal to maximum of m1 comma 2 m2 plus 1. Let us take the maximum. You can see that if this is a maximum number m2, like this, m2 is a maximum number, here m2, here somewhere we get here, this is m2 and this will be somewhere like this, s to m2 minus s is less than epsilon, s to m2 plus 1 minus s is less than epsilon. Here we get this term in the first inequality. Okay, so we take m equal to maximum where both the term s to m minus s is less than epsilon for all n greater than equal to m. That means Sn minus s is less than epsilon for all n which is equal greater than maximum of s to m1 comma s to m2 plus 1. Here I have taken this as a already this as a n, directly this as a n. So we get that this is my n which is greater than 2m. So instead of 2m1 we can write n, already we can write this as a n, and we get Sn minus S is less than epsilon for this 2m1 comma 2m2 plus 1, and hence limit of Sn is equal to S. Therefore the series is an convergent series. This is the proof of this